back. This is Mr. Hassan's Maths channel, and I'm now answering question number 3 from the October-November 2023 Pure Mathematics paper 1 from the Cambridge 9709 syllabus. This is paper 1, variant 3, and this question here is about trig identities and equations. So 3 part A, it says show that the equation 5 cosine theta minus sine theta times tan theta plus 1 equals 0 may be expressed in the form a cosine squared theta plus b cosine theta plus c equals 0, where a, b, and c are constants to be found. Okay, so this has to be written in this form. So before we start, what we should do is just have a look at what we have to form. Now, what we have to form is entirely consisting of the trig ratios in terms of cosine theta and cosine squared theta. Okay, we'll notice that. And what we start with has cosine theta in it, has a sine theta in it, and has tan theta in it. So we have to try to rewrite this in this form. Now, the two identities, which are actually given to you in the formula book in Cambridge examinations, includes these two vital, fundamental identities. And one of them is that the tangent of an angle will always be the same as the sine of that angle divided by the cosine of the same angle. It have to be the same angle, and this will always be true. For any angle, this is true. And also that if you take the sine of an angle, okay, and you square that, and you take the cosine of an angle, and you square that, that gives you 1 always. So, I mean, sine squared theta actually means sine theta all squared. And cosine squared theta, actually, this is what it actually means, but it's written in this form. So if you have the sine of an angle and you square that answer, and you have the cosine of the angle, you square that and you add them together, will always give you 1. And that's true for any angle, as long as they're the same angle here. All right. And what you have to understand that a lot of students mix up with is that this is not true. You cannot say, because of this, this is true. No, it's not true. Sine theta plus cosine theta does not equal 1. It does not equal 1. Okay, you know, if you write that equals 1, that's something that's false. If I put this is equal to 1, okay, that's not true at all. Okay, so that's a mistake that a lot of students make because they think that this follows on from that. They think, oh, take the square root of both sides. But actually, that doesn't make sense. That's not how, these expressions work. So, for example, I can say 3 squared plus 4 squared equals 5 squared. Now, that's true. That's going to be 9 plus 16 equals 25. But that does not mean that 3 plus 4 equals 5. I can't just say take the square root of every term. You have to take the square root of this as a whole. All right, so this is not true. This is true. So in the same way, because this is true, it doesn't mean that's true. This is also not true. This is false and this is false. Okay, so there's a few points that are important where students do make some sort of kind of errors in this identity that we should try to clear up right from the beginning. Okay, so do not write sine theta plus cosine theta equals 1. No, sine squared theta plus cosine squared theta equals 1. Now, with these two identities, we should be able to sort out this problem. So first of all, if you look at what we start with, you can't really do anything except use the identity that tan theta is sine theta over cosine theta. Now, we might not be able to see how every step of the way we're going to get to this result. But in these type of questions, you just go with, you just take the first step, and then that will lead on to what we need. We have to just keep our goal in mind, right? So the only thing you can really do here, there's nothing really else we can do except change the tan theta for sine theta over cosine theta, and that will help us. So let's start off by doing that. So we 5 cosine theta minus, I'll have sine theta times sine theta over cosine theta. The tan theta became, the tan theta here became sine theta over cosine theta from this identity over here. Okay, and then we have plus 1 equals 0. So now what we can see here is, what do we do with this? Well, what we could do, one thing, we could combine these two together. So you have 5 cosine theta minus, that's going to be sine squared theta, that might help us, over cosine theta plus 1 equals 0. Now, what I would think of next is that, look, we don't have any fractions in what we have to show. There's no fractions here at all. Here we've ended up with a fraction now. So let's take this cosine theta and multiply both sides by cosine theta to get rid of that fraction. Okay, and that will hopefully help us. So if I multiply both sides by cosine theta, this becomes 5 cosine squared theta. Remember, I have to multiply every term by cosine theta. Okay, so this becomes 5 cosine squared theta minus, and then when I multiply this by cosine theta, the cosine thetas cancel out, leaving with sine squared theta. And don't forget, the 1 has to also be multiplied by cosine theta, so plus cosine theta equals, and you multiply anything by 0, it stays 0. So I multiplied both sides of the equation by cosine theta, this side and that side, and we ended up with this. Now, it's not exactly what we need here. However, it's getting close, all right? We've got cosine squared theta, we've got cosine theta, but now what do we have? We have a sine squared theta. So we can use this identity over here. We can say that sine squared theta can be rewritten as 1 minus cosine squared theta. So I can replace the sine squared theta with 1 minus cosine squared theta. So you have 5 cosine squared theta minus, now be very careful here. A lot of students make mistakes in these type of questions. There's a minus in front of this sine squared theta. Protect it with this bracket. So you're going to put 1 minus cosine squared theta, close the bracket, plus cosine theta equals 0. Okay, so now when we expand this bracket, be careful of the signs. So you have 5 cosine squared theta minus 1 plus cosine squared theta plus cosine theta equals 0. And so we're almost there. You got 5 cosine squared theta plus cosine squared theta, which is 6 cosine squared theta. We've got plus cosine theta minus 1 equals 0. So now we have rewritten it in this form. We can see here, we don't have to write the values of A, B, and C. This is fine as we've written it, but if you want to, you can. You can say that means A is equal to 6, and B is equal to 1, and C is equal to negative 1. You don't have to write this, as I said. You can just leave it in this form, and that's fine. So we have used these two identities here in order to solve this problem. So I took this identity here, and I replaced the sine squared theta with it. Okay, so I replaced the sine squared theta with 1 minus cosine squared theta. That's what we did there. We ended up with that. Okay, so that's how we dealt with that part, and we ended up with what we need. And there's the answer to that question. Now for part B, it says, hence, solve the equation 5 cosine theta minus sine theta tan theta plus 1 equals 0 for theta between 0 and 2 pi. So here we've got to see, they've given us this limits in radians. So we have to give our answer in radians. Okay, we have to give our answer in radians. So we take our calculator and make sure that it's in radian mode. Okay, so I'm going to do that before we start the question. Angle unit 2. Now it's in radian mode, so that's ready. Okay, so that's one thing we have to be aware of. We have to do it in radians. Okay, now, so what I'm going to do is I'm going to compare what we got with what we started with. So 5 cosine theta minus sine theta tan theta plus 1 equals 0. Exactly the same. 5 cosine theta minus sine theta tan theta plus 1 equals 0. So I can straight away, because it says hence, it means using the answer that you got before. Once I've verified that they're the same, okay, I can now just replace this with my answer that we have got above. So you have 6 cosine squared theta plus cosine theta minus 1 equals 0. So here we have what's called a quadratic equation. It's like a, you can say, disguised quadratics in terms of trig ratios. So some people, to make themselves more familiar, what they do, they would say, let's just rewrite it in a way that's kind of a bit easier to think of. So let me call cosine theta u. That means cosine squared theta is going to be u squared. So wherever I see cosine squared theta, I can replace it with u squared. So this would be 6u squared. So you can choose any letter, b, u, whatever you want. And cosine theta is going to replace with u minus 1 equals 0. Now, one really important point. Okay, a lot of students will now just go to their calculator, use the mode for solving equations in the calculator, and just write down u equals and u equals without showing any steps of how they got there. Okay, now it's really important, and I'm going to show you what the examiner's report for this particular paper said. Okay, so for example here, it says The previous 4 reports each have highlighted that the question paper contains a statement in the rubric on the front cover that no marks will be given for unsupported answers from a calculator. That's mentioned in the front of the paper. Although this message has been taken on board by many candidates, there was still a significant minority for whom it had not. Clear working must always be shown to justify solutions. For quadratic equations, it would be necessary to show factorization, use of the quadratic formula, or completing the square as stated in the syllabus. So you have to show that you've done one of these 3 things. Okay, if factorizing is possible, use factorizing, or quadratic formula, or completing the square. If factorizing is not possible, show that you use the quadratic formula or completing the square. Using calculators to solve equations and writing down only the solution is not sufficient. It is also insufficient to quote only the formula. Candidates need to show values substituted into it. So if you use the quadratic formula, don't just put x equals minus b plus or minus that. No, you have to put the numbers in the right places. Okay, factors must also always produce the coefficients of the quadratic when expanded. All right, so you can't do a cheat and put x minus 2/3 and x plus a half. All right, just using the answer backwards. All right, you have to have it so that the factors produce the coefficients of the quadratic when expanded. The use of calculators to evaluate definite integrals, that comes later. So that's really important for you to realize. You want to lose marks? Go ahead. Just use your calculator here and get the answers. There's no problem using the calculator to check your answer. That's fine. Okay, but you should know how to either factorize, use the quadratic formula, or complete the square to find the values that we're looking for. Right, so if you want to lose marks, then just ignore that instruction. It's very clearly mentioned on the examiner's report and in the mark scheme. So please don't just throw marks away. So when the teachers tell you these things, it's not just to make your life difficult. It's because we want you to gain as many marks as possible. Right. Anyway, let's continue. So we want to try to factorize this. So I'm going to try to factorize it by using the method that I like to teach, this visual way of splitting the middle term. When you have something like this, where you use a number in front of the x squared term, in this case a u squared term, it won't go into 2 brackets that easily. Although this one isn't too difficult, you could do it quite easily. But just to show you this method, so the squared term on the top left, so 6u squared, and the constant term in the bottom right. I need 2 numbers which are going to go in these 2 places. Their product has to be the same as these 2, which is minus 6u squared, and the sum has to be the same as this, which is plus u. Okay, so we can see very clearly it's going to be 3 and 2, and it's going to be positive 3u and minus 1u. Okay, that's going to give you minus 2u, sorry. That's going to give you minus 6u squared, and it's going to give you plus u when you add them. So those are the 2 factors. So now I'm going to look at this row here and take out the highest common factor, which from the numbers is 2 and from the letters is u, so 2u. Then I'm going to say, okay, this square here is a result of this number multiplied by this number. 2u times 3u gives me 6u squared. And this square here is the result of this number times that number. So 2u times minus 1. And this number here is the result of 3u times the number over here. It's like 3u times 1 gives you 3u. So now we have our factors, which are 3u minus 1 times 2u plus 1. Okay, that's a plus 1 there. Equals 0. So now I can say that either 3u minus 1 equals 0, in which case u is equal to 1 over 3, add 1 and divide by 3, or 2u plus 1 equals 0, in which case u is equal to take away 1 and divide by 2 minus a half. So we can now say that therefore cosine theta is equal to a third, or cosine theta is equal to negative a half. Now some of you would have not been very confident with factorizing, and you might have used the quadratic formula, which is perfectly fine to do. There's no issue with that. But when you do it, if you use the quadratic formula for this, you know, you're going to have a as 6, b as 1, and c as minus 1. Don't just quote the formula. Okay, you're going to put your u values are minus b, so you'll put minus 1. Okay, plus or minus the square root of b squared, which is 1 squared, minus 4 times 6 times minus 1, all over 2 times 1, 2a. 2 times 6, sorry. 2 times 6, 2a. So you have to show that you put the right numbers in the right place. And then if you put that on your calculator, it would give you your answer. You'll have minus 1 plus or minus. That's going to give you root 25 over 12. So you end up with, that's going to be minus 1 plus 5, which is 4 over 12, which is going to be 1/3. or you're going to have -1, -5, which is -6. It's going to be minus 6 over 12, which is -1/2. So you get the same answers using the formula, but you have to show at least this step. If you're going to use a formula, you have to show this. Even if you don't quote the formula, using the numbers in the correct place in the formula is what is going to get you the method marks for that. So either you show that you factorized it, or you use the formula, or we can complete the square as well. And those will all, give us the marks. So don't neglect and just write down these answers, because you're going to be throwing away marks, which could cost you a grade. All right, so be careful. So we have these two now sections that we're going to solve separately. We have cosine theta equals a third and cosine theta equals -1/2. Now, for cosine theta equals a third, we're going to use theta equals inverse cosine of 1/3. Now, remember, in radian mode. Okay, now I saw a few strange things when I was marking the papers for this exam for my students. And one of them was this, which I'll explain in a minute. So inverse cosine of a third, that's fine. Radian mode, as we put it into, equals, and we end up with theta equals 1.2309. Okay, I'll write it as that much. Theta equals 1.2309. It goes on. You can write it that much, that's fine. That's the principal solution. Now, some people, for some reason, they added a pi to this. Okay, the answer did not come out in terms of pi. It doesn't say 1.23 something pi. This is 1.2309 radians. It doesn't have to have a pi next to it for it to be in radians. Okay, 3.142 is pi. You can say pi, you can write 3.142. They're both the same thing. You don't put 3.142 pi. Okay, so if the calculator doesn't have a pi with it, then you don't just add a pi to it. Oh, it's in radians, let's just stick a pi there. It's like you're multiplying this by 3.142 and it's a different number. So I don't know why some students, whenever they get a radian answer, which is not in terms of pi, they just add a pi to it because, it has to be in radians. And if it doesn't have a pi next to it, that means it's not in radians. No, that's not true. If the calculator is in radian mode and it gives you this answer, this is the answer. You don't have to add a pi to it. You don't have to stick a pi next to it. Okay, this is the answer in radians. Okay, so that's called the principal solution. Now, with the cosine curve, you get the principal solution, and because our limits are between 0 and 2 pi, as we saw in the question, our limits are between 0 and 2 pi, okay, we have to go all the way up to 2 pi. All right, now 2 pi is basically 6 point, I'll write it here, 2 pi is basically 3.142 times 2, okay, so it's going to be 3.142, so 6.284, something like that. So that's our limit. We can go up to there. Now, if we are solving for the cosine curve, all right, the cosine curve, you can understand how to find the other angles by using the fact that the cosine curve has this type of shape, right? And what we just found was an angle over here. That's the angle we found here. This is the angle in radians over here. Okay, there's another angle which shares the same cosine ratio as this angle, which is over here. And because of the symmetry of the cosine curve, it's going to be, this is 2 pi, which is 360, minus the angle we got there, because that's 2 pi. Okay, so we're going to have, the other angle is going to be 2 pi minus 1.2309, and that will be our other angle. So we'll take this angle, I'll say 2 pi minus the answer. That gives us 5.0522. 5.0522. Okay, so those are our two solutions from this part of the answer, which I'm going to write in the end to 3 significant figures, which is what we're supposed to do for angles in radians. And for the other answer here, cosine theta equals -1/2, I'll do the same thing. I'll put the angle, I'll put inverse cosine of -1/2 and see what we get. So we have inverse cosine of -1/2. And the calculator gives us the principal solution. Now, this is in terms of pi, so we write it as it is, 2 over 3 pi. It's better to leave it in terms of pi instead of writing it as a decimal. So, because it comes out like this is fine. Now, the other angle is going to be, okay, so that's the first angle. The other angle is going to be 2 pi minus this angle, okay? So you're going to have 2 pi minus 2 pi over 3. That's going to be like 6 pi over 3 minus 2 pi over 3, which is 4 pi over 3. Okay, And those are the two main solutions from this. Now, if I wanted to find other solutions, okay, if the range was bigger, I would just take these two answers here and add 2 pi to them to find answers outside or further on than 2 pi. But we can't do that here because we have to stop at 2 pi because those are our limits, which is 0 and 2 pi. So if I go any further than this, if I find other angles which share the same cosine ratio out here somewhere, I'm going to be going outside of the range. So I'm going to stop at these two. So therefore, I'm going to write my answers as theta equals, I've got 1.23 to 3SF. I've got 5.05 to 3SF. Now these I can write them in the exact form, 2 pi over 3 and 4 pi over 3. Those are all the solutions within our range for this question. As I said, you could write this in decimal form as well. You can do 2 times. You could find out what the actual value of this and round it to 3SF. But there's no need to do that. Okay, it's better to write it. If it comes in terms of pi, leave it in terms of pi. So don't add a pi on the end of these numbers, right? Thinking that, you got to stick a pi at the end because it's in radians. No, this is in radians. This is in radians. They're all in radians. These two are in radians in terms of pi. These two are in radians that are not in terms of pi. Okay, so please don't be doing things like that. So there's the answer to this question. Question number 3 from the October-November 2023 exam. Other questions from this particular paper can be found in the playlist that will appear over here. Other questions from the topic of trigonometry, identities and equations from P1 from Edexcel from Cambridge, can be found in this playlist over here. You can subscribe to my channel by clicking on this link, and the video that will appear in this region here will tell you how to use my channel to find the things that you need efficiently. Thank you for watching. See you soon.